Okay, so I'm just going to do a bunch of speed runs this lesson. For the questions, because starting from tomorrow, I'll be away until the end of the week. Given that we go back to school this Wednesday, then I'll be gone next week as well. But if lockdown gets extended, then the outdoor ed camp might get delayed. So I won't be going to that if we don't go out of lockdown. This is what we're going to be aiming to cover today. Handouts in preparation for my absence. So look, if you finish these tasks here at the bottom, if you scroll down to the bottom under resources, chapter 4 and 8 resources, you can see this bit here. Simple interest is the same as linear growth and decay, and compound interest is the same as geometric growth and decay, okay? We just decided to name it so it's simple and compound interest. So it's a bit more comprehensive for you to understand, okay? That will be left for you. That will be work for class on Thursday and Friday. So whoever's taking you on Thursday and Friday, the teacher who's taking you, yeah, first of all, please give them respect as you give me respect. And I'll make a reminder about that at the end of class as well. But also spend that class time to work through it. Otherwise the work piles up. If it hasn't already, it's probably going to pile up just even more, okay? So you got to keep on chipping away at it. This is something I've learned from the daily organizer role. Every morning I have to send an email to all staff, right? And I realized if I wake up at 7 in the morning and I start the work from scratch, then it would take me a lot longer and I'd be under more pressure. Whereas if the night before, just before I go to bed, I set everything up, set up the draft email, and then I close it, I go to bed. In the morning, all I have to do is make very small changes, and then I send it through. So it's about just chipping away at these tasks here. And it's about consistency. Consistency is key, okay? That's what my gym buddy always tells me. So he holds me accountable to go to the gym. All right, I'm going to share, we're going to start off with exercise 8F. I've started a bit on it. But we'll be continuing to build onto it today, okay? So make sure you have your CAS calculators out, just so you can work alongside and yep, just so you can work alongside, and if there's anything, then we can make changes to it. Okay, so 8F is about, so last week on Friday, we learnt about exercise 8E, which was recurrence relations for geometric growth and decay. So geometric is more like compound interest, okay? So get those words to become related to each other when you hear the word geometric or when you hear the word compound, okay? And the other thing is know the difference between a recurrence relation, which is highlighted in yellow here, okay? And in green, that's the rule for the nth term, okay? There's a clear distinction between the two. This one here tells us to calculate it step by step, whereas this one here is like a shortcut and you can just jump straight to the term that you want. I might get you to write the notes after class, just so that you can listen and pay attention and absorb as much as you can now. And then when you go back and when you watch this again on YouTube, you'll be able to, I guess, absorb more of it, okay, as you write down the notes alongside watching the recording, okay? And feel free to pause and stop the video whenever you need to write down the notes. Now, there's 4 geometric growth and decay or compounding. Again, we have to focus when it's accumulating. So when our value is increasing or when it's decreasing. So if it's an investment or a loan that you're taking out of the bank, then it increases. And that's why you see this plus on the equation here. This here would be a capital R, but they just made it very clear and they've substituted in. This looks very familiar, and it's in fact the same equation as not Vn anymore, but if we go back to chapter 4 in our year 11 textbook, it's the same as your compound interest formula. Okay. But that doesn't work universally anymore because it depends on the scenario. In this situation here, in the second scenario, we have what we call a reducing balance depreciation. Okay. So what this means is that the value of the item decreases over time. And I did mention this last week about when you claim items for tax, you either can claim it by a fixed amount, the same amount every year, or you can start off by claiming a lot in the first year and then it gradually decreases. So the second option, which is the gradually decreasing one, is the same as the reducing balance depreciation. Okay. I've done a little summary here. So geometric rule for the nth term. If it's compounding or if it's an investment or a loan, you add, okay? And notice here it's Vn and V0. So being sure to find the very small differences between the recurrence relation and the rule for the nth term. And this over here, just being able to tell the difference, I've just done a little summary of what we literally just talked about, just up here. And I've rewritten it down here. For reducing balance depreciation means it goes down. We need to subtract our rate, okay? The other thing as well is that we need to consider that it's not about this N here. It doesn't represent years anymore. Not that it doesn't represent years, but it represents the compounding periods, okay? So in other words, it's how often interest accumulates, because our rate might be, say, for example, 5% per annum, which is every year. But then what happens if it compounds every week? What happens if it compounds every month? What happens if it compounds every fortnight or every quarter? Okay. If you're doing this exercise now this year, good question, Matt. Your question is, since we are doing this exercise now, will we do it again next year? And also, other classes doing this too in our year 11 cohort? The answer is yes. So I'll answer the first one. Are the other classes doing this too? The answer is yes. They're all learning this year 12 content. Okay. And also, will we be doing this again next year? The answer is yes. So these notes that I'm sending out to you now for this particular chapter, please, please, please keep it. Keep it for next year. There's no guarantee that I'll be teaching you next year. So, because there are other Year 12 teachers already, but the important thing is that what I want you to do is hang on to these notes here, organize your notes, save them somewhere safe that you know you're going to hang on to, okay? And the other thing as well is you might learn this at a faster pace. We've been taking 1 lesson per exercise. Next year we might jam 2 into 1, okay? But let me say this, the first time through when you learn something is always slower than the second time you learn something, okay? If you play piano, if you try to learn a song on an instrument like the piano, if you practice it for the first time, it might take you an hour or 2 just to figure out a few notes. But then the next day, it takes you less time. And then the day after that, it takes you, again, less time. So it's just a matter of exposure. If you've seen it once before, the next time you learn it, it's somewhere in the back of your mind. You'll be able to call it up more quickly, okay? Very good point. So Uma said, we invest in this work now, so it benefits us next year. I think that makes sense. So that's very true. I want you to do the hard yards now, so it better prepares you for next year. And this is what myself, Mr. Narayan, and Ms. Sabu also agreed to as well. We'd rather you just dive headfirst, because look, the thing about maths is if you get it, you get it. Cool? All right. I'm just gonna quickly update here. The roll. And this will be good for those who were away today. All right. So when we talk about the rule, right, this is going to help us jump to whichever year. We don't have to spam the enter button on the calculator on the CAS anymore. Okay. So what we can do is we can just jump straight to that number. So let's go through this question first. It says here a principal value of $10,000 is invested. So it says principal value, that's our starting point. And as you look at this information here, your eyes might also be drawn to the formula or the rule that's been given. And you can see that that's the 10,000 there. In an account earning compound interest. So because it's compound interest, that's why our formula is like this. Is multiplied because it's compound interest. If it was simple interest, then it would be a plus or a minus, okay? At the rate of 9% per annum, so you can see here, is that 0.9 that you can recognize, 0.09. But then why do we get 1.09? Okay, that will be left up to the formula. The rule for the value of the investment after n years, so after however many years you want, okay, which is represented by Vn shown below, okay? Now, I'll just break this one a bit further down, just so you see something that's a bit more familiar to you. So there's our formula that we just mentioned above here. Okay, that's the formula right there. So we're just using it in this question here. Now, I'll keep it like that. This is our focus though. Now, we just need to know how to apply this, okay? So in this first question here, it says, find the value of the investment after 4 years and correct it to the nearest cent. So we want to find the value. So what I've done here in blue is I've done a summary. So we have our formula or our rule, we write it down. we have the information after 4 years. What that means is that n equals 4 because n is after n years, okay? So if it says after 4 years, you match up those numbers and that pronumeral. So you can see that n equals 4. And we also have, we're finding the value Vn to the nearest cent. Now, instead of just writing Vn, you can just write V4 because we know we want it after 4 years. In brackets there, I just put nearest cent. It's a good idea to do that. In our next step here, you can see what I've done is substitute. So should I write that as a step? Substitute into the formula, as you can see up here. All you have to do is just sub 4 into where, or replace the n's with the number 4. Okay, maybe I'll highlight that. There you go. Step 1. Yikes. Substitute. Step 2. CAS. Okay, so if you just type this line directly into your CAS, just to figure out what that number is, you'll find out the value of the investment after 4 years. So if we take out $10,000 and we put it into the bank, then after 4 years, our value will be 1.09 to the power of 4 times 10,000. That gives us a value of $14,115.82. Notice how I use the roughly equal sign. Originally, the number on the calculator shows this. So if we're rounding it to the nearest cent, remember the nearest cent is only 2 decimal places. So we only want 2 decimal places. We look at the number in the next position. Because that's a 6, this 1 here has to round up to a 2. The other thing as well, what is this $14,115.82 representing? It's money. So we need to put a dollar sign in the front. All good, Arafat? Got to hit that dollar sign, yeah? Now,
Yeah.
Yes, very good, man. Maddie, I'm just going to mark you here. That's fine. Just try to come on time or wake up, set the alarms. I know it's hard to wake up these days, especially in the cold. All right. So that's our first part. By the way, if you guys are late, that's fine. I'm recording this anyway, so I'll post it up onto YouTube and I'll post a link. I'll send it to you in the email, and I'll also put it on Compass as well under today's lesson plan. Okay. All right. Find the amount of interest earned after 4 years. Key word here. It's the amount of interest. We're not finding the value anymore. We're finding the interest. Now, if you remember back to chapter 4, the amount of interest that we get is the total amount, and we minus our principal value. So how much your value is now, and then you take away how much you started with. So in this particular case here, it's our value after 4 years. That's our total amount. And we're taking away how much we initially invested, which was $10,000. So that's my little summary there in blue. Our I, or our interest, will be equal to V4, which is the value after 4 years. We've just calculated that up here, so we're going to substitute. And then we're going to subtract the initial amount, which is $10,000. If we put that into our CAS as a calculation, again, rounding it off to 2 decimal places for the nearest cent. So I'm just going to put a roughly equal sign here. And remember, the interest is calculated in dollars. You can write a final statement as well. The interest accumulated after 4 years is $4,000. So after 4 years of putting in $10,000, you actually get back $4,000. That's not bad. That's not bad. Okay. So let's have a look at the next question. Now, so far in part A and part B, we found the value, we found the interest, okay? Now this interest here is compared to how much you put in at the very beginning. So it's across the whole journey so far. But then what if we just wanted to focus? So say for example, if on the graph, right? Here's $10,000. We put in an amount and it goes up like that after a certain amount of time. Here it is after 4 years, let's just say. So what we just calculated in part B was how much we earned across the whole thing. So from here to here, how much money it took to get from $10,000 to $14,000. You can see in that little graph there. But in this next question here, let's have a read of it. It says, find the amount of interest, so just the interest, earned in the 4th year. Now you have to be very careful with the wording here because after 4 years and in the 4th year are totally different things, okay? So after 4 years compares to when you start, but in the 4th year means that you're looking in just within 1 year, how much interest you got in 1 year. So compared to this here, if we look at our timeline, here, what we're trying to do is we're trying to calculate it in the 4th year. So let's have a look at the note here. It says this means that the interest accumulated on the value after 3 years. That's what V3 is. The value after 3 years. I'll just write that there. So if you have a look, and I listed it out, this is the value after no years. At the very start, what I meant is at the very start, this is the value after 1 year, the value after 2 years, the value after 3 years, the value after 4 years. From V0 to V1, that's calculated out as our 1st year. The 2nd year is between V1 and V2. The 3rd year is between V2 and V3. And the 4th year is between our value after 3 years and the value after 4 years. Okay. So in the book, it calculates it as a percentage of V3. But what I like to do is I like to calculate the value of the 4th year and then the value of the 3rd year. So that's the amounts, right? That's the values. So I'll get rid of it on here just so I can show you and illustrate this. Here's the value after 3 years. So if you want to find out how much you gained or how much interest you made, you take this value, the higher value, which is at 4 years, and then you subtract it with the value at 3 years. Because that's how you're going to find this distance between, or the amount of money between those 2 points. So let's take that. I'll keep this graph here just so you can see what it kind of looks like, yeah, a way to visualize it. So we've already have the value after 4 years. That's the great thing about it. So I'm just going to write that down. And we're also going to calculate now the value after 3 years. So the value after 3 years, if we go back up to our formula here, we've got V3 equals to 1.09 to the power of 3 times 10,000. If we put that into our calculator, we should get $12,950.29. So then the interest in the 4th year will be equal to, remember what I said here? Find the difference between the two. So we're subtracting the bigger number from the smaller number. And that's how you're going to find how much you gained over that certain amount of time. Again, keep this in mind. The first time I explain this, it might not completely make sense. Go off, try it, and then go through it again, okay? Maybe watch over it again. And you only come to understand something if you struggle with it yourself, okay? It's important that you struggle with this yourself first, because you can't expect to have everything handed to you on a silver platter. So that's our final answer there. Our final answer shows that the interest in the 4th year is $1,165.53. Okay. Now what I'm going to do here is I'm going to copy and paste this page. So we're still working on this question here. It's just that we need to go on to the next question. So I've still got that up here. It's not gone. All right, we're just moving on to part D now. Remember to pause and rewind if you feel like you didn't catch everything that I said, okay? So just pause the video and rewind. Now this next question here asks us if the interest compounds monthly instead of yearly. Okay. What we need to figure out is what our rate is at the moment. Okay. And then we need to write down a rule for the value of the investment after n months. So what do we have at the moment? If it compounds monthly, what that affects is that it affects your rate. So this idea of compounds monthly this here affects the rate. And I'm going to say the rate little r, okay? So our rate at the moment is 9% per annum. Where did I get that 9% per annum? That's just from the top here in the information you can see in the blue section, 9% per annum. But it's not compounding per annum anymore. That's per annum. it's compounding monthly now. So if we want to change this rate, instead of writing per annum, I'll write per year. If we want to change this rate to per month, what we need to do is divide it, because if we're looking at a month compared to a year, a month is smaller. If you want to make a number smaller, you don't multiply, you divide. So in this case here, we're going to go 9 divided by 12. Okay, you can simplify this if you want, but I'm going to keep it as 9 over 12 because you can see that's 9 months out of 12 months. So that's 9 months out of a year. So what this means now is that our rate is, our rate is calculated on that small period there. Okay. So when it comes to our formula now, I'm just going to write our formula for this compound interest once again, or our rule. Remember that it's a plus because we are dealing with compound interest and we're talking about investments. Okay, there's our rule there. Where can you find this? Make sure you look up into your notes. If you can't remember it, then you need to actively flick back, scroll through the notes. So scroll through, look back up at the notes, recognize the title. This is what we're dealing with. We're dealing with investments, okay? And it's compound interest. Then you look at the rule. Okay, so you need to know, developing the skill of how to look for things in your notes is so important. Make sure you flick up your notes. So once we've got all of that, we need to write down a rule. Okay, we need to write down a rule. That's what it's asking us for. Write down a rule for the value of the investment. So it seems like we've got all our ingredients here. We can actually find now any value of time of any value after any month. Now that we've got our rate, so it's 9 out of 12 over 100 to the power of n times V0. Do we know what our V0 is? Our V0 is our principal amount, which is how much you put in at the very beginning. That's correct. Not 1,000, but 10,000.
I said 10,000.
Oh, okay. I think the audio kind of chopped off a bit. Thanks, Matt. Okay. So you can see there, that's our rule. The only thing we need to leave unknown is these n values here. Every other value we can fill out. You can put this into your calculator now to make this more simple, okay? So just chuck this into your calculator, just this section here. Because we can turn it into a nice number. So I'll just share my CAS screen with you. Bear with me for a second. On the CAS here, I'm just going to type in that calculation within inside the bracket. So I want a fraction. So see that fraction on top of the divided sign. I'm going to bring that up. we've got 9 over 12. And then in the denominator, we have 100. Control Enter to find out our rate. I'm going to see if I can copy this over into our notes. Can't do it at the moment. Okay. Give me a moment. Bear with me for a moment. I'm just trying to troubleshoot this. Let's try this again. Yeah, no, still not working. Look, so that's what it is. That's what you type into the CAS. I'll just hop back over here. And I'll write down the value, which was 1.0075. 1.0075. And this is to the power of n. We don't need to put brackets anymore because that is just grouped into one whole number now. And we times it by our 10,000. Okay. There it is. We still have our n's. All we did was that we simplified this bracket here. We calculated what that value is. So that answers part D. And now it says in part E, use this rule to find the value of the investment after 4 years. So after 4 years, that's what we want to do. I'm just going to write part E here. Again, after 4 years. Now, what this means is it n equals to 4? The issue here is we need to remember how often it's being compounded. Okay, so this rule here, for this particular rule, it's compounding monthly. I think that's worthwhile noting down on the side. So the fact that it compounds monthly, we need to convert all of our units to months. So this n value here wouldn't be 4. We need to convert this 4 years into months, which is, well, how many months are there in 4 years? The number of months, there's 12 months in a year. So after 4 years, that's 4 times 12, which is 48 months. This means here that our n value will be 48 because it's after 48 times that the interest compounds, or the interest is calculated 48 times. So let's have a look here. We've got our V. It's not V4 anymore. Our N is 48 because it's after 48 months. We're going to go 1.0075 to the power of 48. And we multiply that by 10,000. Substitute that into the calculator. And what we end up with is $14,314.05. So let's compare that. If we compounded yearly, if we compounded yearly, just once a year, after 4 years, you can see our value is $14,115.82. That's if we compound yearly. So every year we just calculate our interest just once. Now let's compare that with if you compound it monthly. Which one gives you a better return? This is a yearly compound. Or is this a monthly compound? Compare the numbers at the end there. What you notice is that if you compound monthly, you actually end up earning more money. And it's a big difference. From 115 to 314, that's roughly $200 of difference. You're getting an extra $200 if you compound monthly rather than compounding yearly. So if you want to get more interest for yourself, if you're investing, then if you have regular compounds, it would be better. It would be much, much better for you rather than opting for the yearly compound. That's given if you have the same interest rate, okay? Don't assume that from now on that monthly compound's better, but you need to run the calculations first and provide solid evidence mathematically first, and then you can make a decision, okay? So that's a tip there. Always have hard evidence first. Don't assume, because as soon as you assume, you're not basing anything off evidence, okay? We're talking about numbers. When we talk about money, we're talking about numbers. You need to have the numbers out. So what I'm going to do is there's a lot more examples here. Example 20, example 21, and example 22. We won't have time to go through this in class because I would like to cover exercise 8G as well. So what I might do over the next couple of days is I'll write a solution. I may do a recording of myself and just walk through the question. If you can, please watch this so it can help you out, okay? So I'll create some videos. I'll put that on my task list and to do things, and then chip away at them. Because right now we're going to go on to the next topic. Which is nominal and effective interest rates. Okay, I'm going to summarize it for you here, so I'll give you the condensed version. When we look at nominal interest rates, and this is the rates that banks would put on their front page when they advertise something. They always just say 5%, 4%, or like 7%. But they don't actually tell you how often it is. And they deliberately do that to confuse you. They'll actually say just 5% because you'll be like, oh, that sounds pretty good. But say, for example, if you put 5% per annum, and it doesn't sound that great, it limits it. When people see just 5%, they'll think, oh my God, 5% per month? That would be awesome if I was to put my money into this bank. So they deliberately just leave it at 5%. But just know that every time when you see that on any bank, it's 5% per annum, okay? This is what we call the nominal interest rate. So the nominal interest rate, if we have a read here, compound interests are usually quoted as annual rates. So the interest rate is per annum. Even if it's compounded daily, if it's compounded monthly, fortnightly, weekly, monthly, quarterly, you will still convert it to and present it to everyone as per annum, okay? That's what the nominal interest rate is. So if you have something in per week, you have to convert that to per annum. That would be your nominal interest rate. And that depends on your compounding period. Again, how many times are you getting paid this interest within 1 year? So this here is a, you know what, I'm going to take this note, I'm going to slap it into our notes. So at least you have the definition here, and it's not too much clutter when you look at the textbook. Here are the rates that you'll be dividing by, okay? Here's your conversion unit. So when we talk about months, there's always 12 months in a year. When we talk about quarters, we have to divide by 4 because there are 4 quarters in a year. Fortnights, there's 26 fortnights. Weeks, there's 52 weeks in a year. And for the amount of days, there's 365 days in a year, okay? What we generally do is we ignore the idea of leap years. You know how there could be 366 days in the year? We ignore that for financial purposes. We want to keep it consistent, okay? So we just use the base date of 365. What I might do is I might highlight this for you guys. So you have this in your notes. Pretty important to hang on to, or pretty nifty too. I won't fill it, I'll just put a box around it, okay? So if we jump directly to a question here, it's best demonstrated as such. Now the question is, if an investment account will pay an interest rate at 3.6% per annum. Okay, so notice how it's presented to us as per annum. It says convert this interest rate to a monthly rate. So say, for example, the bank presents, you're going to get 3.6 per annum return when you put money into the bank, but it compounds monthly. So we need to find out our nominal interest rate. This is how we calculate it. So for part A, monthly, that's the key word. So what that means is we need to divide our per annum by 12. So our nominal interest rate equals to 3.6% per annum. And we divide that by 12. It's not per annum anymore. It's now per month. Let's just chuck that into the calculator so we get a nice number. 3.6 divided by 12. That equals to 0.3% per month. Simple calculation. So Next one, I'll just do it. The key word here is a fortnightly rate. So fortnight is every 2 weeks. We need to find out what our conversion unit is. Now, if you forget, just please scroll up, have a look for the keyword of fortnights. At the top there, you can see it's 26 fortnights. And if you forget, if you need to multiply or divide, just read, okay? A nominal interest rate is converted to a compounding interest rate by dividing these numbers. There it is, the key word, dividing. It just depends on what you're focusing on for your keyword. So here we need to divide by that number, which is 26. So our nominal interest rate will be 26. Oh, sorry. We get our 3.6 and we divide it by 26. That becomes percent per fortnight now. .6 divided by 26. That gives us a value of, now I'm just going to round it to 2 decimal places here. Let's just set the condition there. 2 decimal places. So here we'll do 2 decimal places as well. For the first question, it was perfectly 0.3. But for this one here, 0.14% per fortnight. Last but not least, quarterly, and I'll let you do this yourself. When you see the word quarterly, go up to this yellow highlighted box, recognize, try to look for the word quarters. We need to do something with this 4. We need to divide it by 4. So what are we dividing by 4? We're taking our annual rate, so our rate for the year, and we divide it by 4. That will give us our rate per quarter. Okay, so same process. So when I talk about process, it's the steps that you take. Yeah, people get this mixed up and then they end up copying the same numbers into that question. So if you take these numbers here and you copy that into this particular question, that's going to be completely wrong. You need to be able to compare and tell the differences, what number you're changing. Okay, so what I'm trying to develop here, or asking you to develop, is just attention to detail. You need to pay attention to the small details. That's nominal interest rates. That was pretty straightforward. But then we actually have to find what we call the effective interest rate. Okay? What the effective interest rate is how much interest you're actually earning, because our interest rate isn't the same. We don't get the same return every single payment we get back. Okay, so after a certain amount of time, depending on how often we get paid or how often this interest is earned or accumulated, you'll start to recognize, and here's a table here. This is a fantastic table here because it shows you, if you know how to read this, it shows you very clearly the difference between how often you accumulate your interest. So if you have a look at this first column here, notice at the top it says 4% per annum. Okay, so this means that you only get interest 4.8% after the whole year. So from $5,000, After 1 year, after 12 months, you get 5,240. So to start from 5,000 to get to 5,240, you take the bigger number, you subtract the smaller number, and that's how you get your interest, okay? So that amount of interest there, what you do is you take that and you find it as a percentage of how much you earned. That gives you an effective rate. So how much is it effectively? How much are you earning? That's 4.8% because it's just calculated per annum. But let's say now we actually accumulate our interest every quarter. Every quarter means, what's a quarter? 12 months. 3, yeah? So every 3 months, you're going to get interest. So how did they get this 1.2%? The way that they got it was that they did 4.8 divided by 4. That will give you 1.2%. I might label that there so you can see 4.8 divided by 4. Okay. If you want it for per month, it's the same as 4.8, but per month means that you divide by 12. Keyword month, go back up to the table, look for that 12, and you're good to go. Now, you can see here that this compounds a total of 1, 2, 3, 4 times in the year. But then at the very end, if you take our number at the very end and you compare it to our number at the very start, you can see that we actually got more interest. We actually earned more interest. So if you compound more regularly, that seems to be better. If you have the nominal interest rate, but then you calculate it based on how often you get paid, it's better to be paid more often or to get that interest accumulated more often. Now, you can see here, if we do it every single month, this is how much we'll end up earning. Now, it just seems like a very small difference, but the effective interest rate, if you actually put in more money, this gap here will become even bigger, okay? So, well, compared to, if you compare months to years, you're earning an extra whole $5 on that. Keep in mind that you're only putting $5,000 in, okay? What happens if you put $100,000 in? Every year you'd be earning a fair amount, okay? So definitely something to keep in mind. And we like to talk about banks because this is the system that they use, and it's important for us to understand how banks work. So you get more bang for your buck, or you don't lose out, okay? So how do we actually calculate this? Once again, there's a formula for it. I might just take this table here and I'll slap it into our notes. And I've made a mistake here. Remember, nominal interest rate is just calculated per annum. So this here is actually our nominal interest rate. I'm so sorry. Because it's calculated per annum. So this here is not our nominal interest rate. These here, these are just our interest rate per month. Or you can say, instead of saying per month, you can say monthly interest rate. And this one here is fortnightly interest rate. Okay. Nominal is for the year. Okay. Sorry, I made a mistake there. All right. So how do we actually apply this to a question now? I'll take this note here as well, because we actually have a formula for it. And I'll show you how to do this on your CAS as well. I'll see if I can get this CAS stuff working again, so then I can copy and paste and complete the notes properly. This is going to be important for your SAC, so please take note. Please pay attention to this one. So Brooke is deciding, we've only got a couple minutes left, so I'll try to run through this. And I'll show you how to do this on your calculator as well, okay? There's instructions for it in the textbook for you to do it on your calculator, so do have a read through that as well, from the PDF, from the textbook. But let's have a look at this. Brooke would like to borrow $20,000, okay? So she's borrowing money. She's deciding between two loan options. So if you think about it, if you're borrowing money, you're eventually going to have to pay them back, right? But you pay them back and the bank is going to make interest. So the bank is gaining more money here. We want to pay as less as the customer, right? We don't want to pay the bank too much interest. Okay. So what we're going to do is we need to figure out which one pays less interest. We have the formula here. Sorry, I didn't go through this formula, but we just need to apply it, okay? Yes, it is, yes, there is a percentage sign at the end, but what you're going to do is you're going to drop that when you put it into the CAS, okay? You're not going to type in percent in the CAS. You just type in the numbers. So if we have a look at option A, we have our nominal interest rate, which is per annum. So that's the nominal interest rate. I'll write that down as a summary. That's 5.95% per annum. And the other thing is that it compounds weekly. You can just write compounding weekly because that's the same language in the question. So this idea of weekly is, if you look up, is 52 payments in a year, yeah? 52 weeks in a year. So that's what that's why I wrote that 52 there. Now we've got our formula. So for the effective interest rate, I've just done R for rate. And you can see this EFF here is at the bottom. So it's called subscripting. We write it at the bottom. We've got 1 plus R divided by N over 100. And we put this to the power of N, take away 1. All we need to do now is substitute. We know what our R is, our nominal interest rate, that's for the whole year. We divide it by our N. Now, perhaps I should make it more clear here. The The 52 here represents our N value, and this 5.95% represents our rate for the year, okay? So you can see R is 5.95, N is 52. So what we're going to do is we're just substituting them in. So compare the top line with the bottom line that I'm currently writing. And you can see that the numbers change to whichever number it's representing. You're going to type this into your CAS now to obtain an answer. Oh, it seems I've forgotten to multiply it by 100 as well. So you get the actual percentage. So you need to type this whole bracket in, okay? Make sure you put all the brackets. Be very careful of how you type it out on the calculator. This should give you a value of 6.13% per annum, okay? So what that does is that it tells you how much the effective interest rate, once again, is also in per annum, okay? So you just need to keep an eye out for that. We're also going to look at option B. It says here that it's compounding 6% per annum. So I'll just summarize this really quickly. Our R is 6% PA. And the number of compounds we have is that it's compounding quarterly. So we actually have 4 quarters in a year. So N equals 4, so it's quarterly. Once we've got that, all we need to do is substitute it into our formula and calculate it. So there's our formula. We're going to make the substitutions. We've got 6 divided by 4 over 100 to the power of 4 minus 1. Close that bracket off. I feel like I've got an extra bracket here. Times 100. Again, if you want to get this right, you need to really pay attention to the detail. I believe the answer here was 6.14. Just gonna grab that off there. 6.14% per annum. So if you look at both of these and you compare now the effective interest rate, which one should you choose if you want to pay less interest? Option A or option B?
A.
Option A, because if you have a look at the numbers, the only difference is that that one's a lower compared to the two. So when we say lower effective interest rate. Okay. So that explains exercise 8F and 8G. Try to go through the questions with the notes. Definitely have the notes there and try to decipher the questions, okay? I'm going to leave that with you. I will send off these notes and I'll upload everything, okay? So thanks for tuning in. I know it was a very content heavy question and I did most of the talking. In fact, I didn't ask any of you, I barely ask anyone any questions. But we just had to get through that content there because I won't be here for the next 2 days or next 2 sessions. All right, we'll leave it at that. We'll catch you next week. Okay. If you have any issues, email me during the week. Thanks, guys.